Beautiful. Okay, ladies and gentlemen, before we get going real big time today, you had a worksheet 3.3, and you had a mix 6, and you had delta math. Okay, several of you guys did not upload your picture of your unit circle. Get that uploaded to me. It's on. It says unit circle. We've done 3-1, 3-2, 3-3. I did not look at 3-3. I didn't look at 3-3, so you don't have a grade for that yet. I'll do that during prep today, second hour. I'll look at your 3-3s. Okay, so I didn't look at that. I like to look at it first, so that way I kind of know where you guys are at. That's why I kind of went around and asked this morning to make sure we're good. So 3-1, 3-2, 3-3. Today we're going to do 3-4, 3-5, and then we're going to do a quiz over 3-1 through 3-3. Okay. Because we're doing 3-4 and 3-5 today, because we did 3-2 and 3-3, we're doing pretty good. I don't think I'm overloading you with information. A lot of this gets combined in together. You'll see today. I mean, you won't even notice a difference between 3-4 and 3-5. And really, you kind of know all this stuff. It's kind of those things what you know, we have to put together. So again, we'll get to that in just a second, okay? Great questions on the mix 6. Those are more AP-ish style, okay? You got to know the basics in order to do the AP style type questions. So those are questions that are more in depth, okay? Just kind of make sure we're always, that's why I gave those to you. I didn't want it to be completely foreign to you. What questions do you have over 3-3 worksheet, or if you have the mix 6, or if you had a delta off the top of your head? I don't have the mix 6 electronically. I do have the answers somewhere, I think. I didn't post them, did I? I don't think I posted the mix 6. I have them somewhere. Miss Gross sent them to me, the answers. But anything that you need cleared up before we start 3-4, and the reason why I want to start it first, that way, because some of you guys will not take very long at all on the quiz, and I don't want you just sitting there waiting for everybody to get done with the quiz. So I do 3-4 and 3-5, do the quiz, and that way those of you get done with the quiz have something to do for homework, the 3-4 and 3-5. Good enough? Okay. What questions do we have before we do 3-4 and 3-5? Any questions over the worksheet? Anything about delta math, or anything about the mix 6? Y'all are feeling comfortable? Anything at all about it? Okay. Again, it's the big picture. If you can do the unit circle, again, I don't like for you to have it memorized. You kind of will by the time we get done, but if you have to, just draw the thing. Just draw circles and tell me about where that thing is, and then you know if it's the short side or the long side or the square root of 2, but some of them you don't have to draw. Anyway, these you got to know. You just got to know. If I see sine of pi over 4, you got to know that's square root of 2 over 2. And the faster you know that, the better off you're going to be. And if it takes you a little bit longer, take a little bit longer, because if you miss that, you're going to miss a whole lot of stuff. Okay? This stuff comes up the rest of the semester. You got to know that cosine of pi over 2 is straight up in the air and the duck's falling right in the boat, and cosine is K9, which is my dog, so that's 0. And whatever you got to do to go through that whole thing. And some of you guys will have it memorized by now. But if you have to think about where pi over 2 is, that's fine. It's okay. You got time to do that kind of stuff. But the faster you can do it, the more time you have to think about other things. You for sure have to know those points, though. And that's why I gave them all those to you, right? I've not done yet. In fact, one of our quizzes very possibly will have 20 of these things on there, and I'm going to give them to you and say, boom, here, have at it. Give me those values. And really, you only have one of, it can only be a 0 or a 1 or a negative 1. 0, 1, negative 1. Root 2, 2, negative root 2, 2. 1/2, negative 1/2. Root 3, 2, or negative root 3, 2. And those are really the only choices you have. Yes, sir. So at some point there will be, right? So this, we haven't done that yet, okay? And I don't think, I haven't even looked at the quiz. I wouldn't know what a single question was on that thing. I don't do that. I don't look first. I wouldn't think, because we haven't done anything in class-wise. I've told you, but we really haven't done homework-wise, except for the delta math of the tangent, cotangent, cosecant, secant. Okay? Those we have to know at some point, but if you know sine and cosine, then you know those other ones. And yeah, it takes a little bit more work to get those, but after you flip some of them so many times, you'll know what they are. Right? The 45s or the power 4s for tangent are real easy because those are ones. Because sine and cosine are the same. So, good question. One that I really don't have a great answer for you yet. At some point, you for sure need to know those. I don't think you need to know those for the quiz. What else? Anything else? Anything else before we get going? You guys been doing pretty good on your, like I said, I haven't looked through 3 yet, but I saw your unit circles. Most of you guys did. Like I said, some of you haven't uploaded your picture of the unit circle that y'all filled it out online. Go to that website, get a screenshot of it or take a picture, whatever you got to do. I just want to see how many you got right and how long it took you. And I don't care how many you got right, and I don't care how long it took you. I do care how many you got right. I really don't care how long it took you. Hopefully, you're not having to look at a unit circle to do it. That's the goal. I don't want you to have to look at the unit circle to do it, because you're not learning it that way. Hopefully, you can figure it out, or you have it memorized, either way. Okay, good. Here we go, 3, 4, 3, 5. 3, 4, 3, 5 notes. I haven't looked at your notes compared to these, but they should be pretty close. A lot of this is going to be extra. I told the other teachers, I said, we're going to go through 3-1, or not 3-1s, but well, maybe all of them, and cut out a lot of that stuff, because I told you in 3-3, you got a lot of notes that are extra. I think they're confusing. To me, they are. And I think there's a lot of extra stuff in here. If you read it, it goes in depth and it explains it, but So far, Unit 3, we have learned how to define sine and cosine values for angles and standard positions, and how to measure angles in radians, how to use the unit circle to evaluate sine and cosine functions at given angles. Now we're going to put all of these together and discover that they can help us develop and understand how to represent sine and cosine graphically. Okay, we're going to graph sine and cosine. I already didn't know that's the unit circle. That's not graphing sine and cosine. That's x squared plus y squared equals 1, which has nothing really to do with sine and cosine. We're going to start by considering the function f of theta is equal to sine theta. Fx equals sine x. A lot of times they get away from x's on this and they go to thetas for angles. Since we know that angle measures in standard position are periodic, we can expect f of theta to be periodic. Let's talk about that for just a second, because that was 3.1. We talked about being periods, right? Repeat. And you guys can picture in your head, or at least I hope you can somewhat, that as that stupid radius thing, let me do it your way, as it's going around, at some point we start repeating those values, right? We're at 1/2 here, and we're at, depending on if it's sine or cosine, but sine, we're at 1/2 right here. So sine is 1/2 here, and it's 1/2 here. And then we got to go all the way back around, and then it's 1/2 again, and 1/2 again. It's 1 up here. All the way back around, it's 1 again. All the way back around, it's 1 again. So sine and cosine are periodic because they repeat after so long. Okay, so that's what they're talking about. We expect. Also, since theta is our input values, we're going to use the horizontal axis for our angle measures. And we're not using degrees, we're using radians. And so typically you don't want your horizontal axis to go 0, 1, 2, 3, because you guys found out by doing your delta math, 1 radian is not really anything clean at all. and 2 radians is not anything clean. However, 3.14 radians is clean. So instead of going by 1, 2, 3, and 4, we'll typically go by 1 pi, 2 pi, 3 pi. And we might even do a half pi. We might even do a third of a pi. We might even do a sixth of a pi, but you learn now that some of those are not very clean numbers. Square root of 3 over 2 is not a clean number. Square root of 2 over 2 is not a clean number. 1 over 2 is clean, but it's really not even that clean because that's a half. They'll kind of follow what we're along, right? So we got a lot of non-clean numbers. It's kind of like exponentials and logarithmics. With logarithmics, we don't have a whole lot of clean numbers. We don't have a whole lot at all. In fact, a lot of times with logarithmics, we only have like 2 clean numbers, at 0 and at whatever it takes to become the 1. All right, here we go. Anyway, so this is what they're talking about right here. These are my input values, and these are my input values, and I'm going all the way from basically, they don't have 0 on here for some reason. I would think you would start at 0. We go out to pi, and then we end at 2 pi, which is 0. But I like to start at 0 and then end at 2 pi, and hopefully, you know, we're at the same point. Y'all okay? And all we're doing right now is filling out an XYT chart. And a lot of these are really, really, really nasty numbers. So let's just kind of go along here. I'm not going to do it with the nasty numbers, but I do want you guys, there's a unit circle over there just for your enjoyment. I'm going to go through the notes and get rid of all these unit circles because, again, I don't want you guys kind of really cheating and looking at that. I want you guys to know it without having to look at this. The more you have to look at this, the worse off you're going to be in this class for this chapter. Hopefully you know that sine of pi over 6. Pi over 6 is just that first one up, so that's the short side, so that's simply 1/2. And hopefully you know that. So 1/2 or 0.5, we're graphing this, so I don't care if you do 1/2 or if you do 0.5. Okay. Sine of this is square root of 3 over 2, which becomes nasty. I think it's like 0.86. I'm going off memory from 11th grade. I didn't have any of these memorized, so I just cheated. I just always put sine. Anyway, 0.86. Mr. Sharp, you good back there? Kind of giggling a little bit. I don't know what I've said funny yet. Pi over 2. Pi over 2 straight up in the air. That's easy because when sine is straight up in the air, that's when the duck is 1. Y'all okay? So we have clean numbers and we have not clean numbers. At some point, we're going to skip all these nasty ones and we're just going to focus on the zeros and the ones. Focus on the zeros and the ones and the negative ones. 2 pi over 3 will be also 0.86. And then this is the 0.5 because 5, 6. Let me do it your way, right? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So that's 1/2, it's 1/2. And then we're at pi, which is 0. Okay, and again, that's the important one. Not necessarily the 0.5s and the 0.8s, but the 1s and the 0s, because again, it's periodic. 7 pi over 6 is now negative 1/2, negative 0.5. This is negative 0.8. Did somebody check me on this? I don't want to give you 0.86 and it be wrong. I think it's 0.866 something. Negative 3 pi over 2. The duck is straight underneath the water, so that's negative 1. Then we're back at this negative 0.86. Let me make sure that that's right. It is. Seriously, it's the other one's square root of 2 over 2 is like 0.707, I think. Check square root of 2 over 2. Is that right too? Man, seriously, I haven't done that since 11th grade. So 11 pi over 6 is the negative, the 0.5, and now we're back at 0. Okay? So, as typically when you start learning how to graph things, we make an XY, we just plug and chug. We plug and chug until we get points. And so we're going to plug and chug. We plugged and chugged. We got points. So at 0, we're at 0. Now, again, we didn't do that one, but you should know that one. That's one of the big points. When you're at 0, sine is 0. When we're at this, we're at 1/2. And here we're at 0.86. And then finally at here, we're at 1. Okay? And this is not, because it's a circle, this is not linear. It's not linear. And you can kind of see it's not linear. It looks curved. And you've also learned that the values of sine never get any bigger than 1, because the highest or the furthest that could ever be is 1, because it's tied to a rope. It's tied to a rope. So it's 1 away always. It's 1 away always as the hypotenuse. But sine it's 0. Sine is 0 here. And then I'm getting closer and closer and closer and closer to 1. And then I'm getting closer and closer and closer to 0. So we're going 0.86 here. We're going 0.5. And then we're back at 0 at pi. And that's half of the graph of sine, if you want to say that. And then we're going back down here. We're at negative 1/2. We're at negative 0.86. We're at negative 1. We're at negative 0.86, negative 1/2, and back at 0. And so if we connect all these dots, it ends up looking like that. Remember this. That bad boy keeps on going. It keeps on going because it is periodic. And not only does it keep going this way, it keeps going that way, because we have negative angles. We can go this way. So sine is periodic that starts at negative infinity. The domain for sine is negative infinity to infinity. The domain for sine is negative infinity to infinity, because it never stops that way and it never stops that way. However, the range only goes from negative 1 to 1. Because the smallest it will ever be is negative 1, and the biggest it will ever be is 1. And it can be those values, so we will use brackets. Just this, I don't know if we're talking about that yet or not. I'm just putting all this stuff in your head that you guys already know. Y'all okay with sine? Beautiful. I just always think of sine starts at 0. So at 0, we're at 0. At pi over 2, we're at 1. So I don't typically worry about the halves and the 0.8s. I hit the 0, I hit the 1, I hit the 0, I hit the negative 1, and then I hit the 0. Kind of like the square root function. I don't worry about the square root of 2. I don't worry about the square root of 3. I worry about the square root of 4, because those are clean numbers. And then I don't worry about 5 or 6 or 7 or 8. 9 is my next one. I want clean numbers to graph. So I typically hit well, now, here we go. Stop. I'm talking too much. Here's some definition of some words we got to know. Okay? Midline. Midline. That's halfway between it. Typically, it's the x-axis. Typically, it's the x-axis. Midline is typically y equals 0. Guys, it's an equation. It's an equation. Y equals 0. Horizontal line. The midline is always going to be horizontal. Most of the time, it's at 0. If we move this thing up, it's no longer at 0. And you guys have learned about moving graphs. We can move graphs up, down. We can move them left. We can move them right. Although this one's a little weird by moving it left or right, because at some point it starts repeating. We can stretch them, shrink them, stretch them, shrink them. And all that's getting ready to come into play. But it's all stuff you already know, luckily. So the midline is wherever that, again, where the midpoint is of that graph. Most of the time it's at 0, unless we get moved up or down. Amplitude is the distance from the midline to the max, or the midline to the min. However, it's always positive because it's a distance. So the amplitude is typically 1, unless we stretch or shrink it. But if we move it up or move it down, it's still 1. If we move it left or right, it's still 1. Amplitude is from the midline to the max. That's why I always say it, because you're less likely to mess up. You go midline to the min, Some people put negative, and amplitude is never negative. The period is typically, I shouldn't say always, it's typically 2 pi. How long does it take for me to repeat? 0 to 2 pi, or from pi over 2 to 4 pi, 5 pi over 2. Wherever from wherever. Because we're going to continue on. From here to here. Here to here is not the period. That's not the period. That's not a complete cycle. That's the complete cycle. Typically, it's 2 pi unless we shrink or stretch this thing. But if we move it left or move it right, it's still 2 pi. If we move it up or we move it down, it's still 2 pi. The only time it's not 2 pi is if we stretch or shrink it. I'm doing that backwards. Period. Okay? The frequency is the reciprocal of the period. I don't use frequency much. We never use, this is AP. Frequency is new to me. But it's 1 over the period. If you can remember that, you're going to get it right. So the frequency is the reciprocal of the period. The frequency is the reciprocal. Of course, hopefully you guys can understand it isolates between concave up and concave down. It's concave down, it's concave down, it's concave down, it's concave down, it's concave down. Now it's concave up, concave up, concave up, concave up, concave up, concave down, concave down, concave down, concave up, concave down, yada, yada, yada. Good. We know it's increasing, we know it's decreasing, we know it's concave up, it's concave down. It increases at a decreasing rate, it decreases at an increasing rate. This is one of those that does all 4 things. Depends on where you're talking about, from where to where. Most of our graphs, parabola is only a concave up. These are everything. They're concave up, they're concave down. They increase and they decrease. Almost like a polynomial type thing. All right, everybody good? Cosine. Cosine. The difference between sine and cosine, well, here, red. The difference between sine and cosine is at 0, sine is 0. But at 0, cosine is actually 1. They didn't start that. This is the square root of 3 over 2. So this is the 0.8, this is the 0.5, and at pi over 2, we're at 0. I'm skipping all these other ones that I really don't care about. Now I'm at a 0.5 again, I'm at a 0.8, and now I'm at 1. Again, 0.5, 0.8, well, I'm getting closer and closer to 1. Oh, it's not 1, it's what? -1. And these are negative. Sorry. Those are negative values. Yes? Yes. Yeah. Yeah. Cosine's positive. Cosine has to turn around. Okay? -0.8, -0.50, -0.5, +0.5, 0.8, and then back at 1. Cosine starts at 1. When we get to pi over 2, we are at 0. These are the big point. There's 5 points I'm concerned with, 5 points. The midlines and the maxes and mins. 0, pi over 2, -1, -1 at pi, back to 0 at 3 pi over 2, ducks underneath the water, cosine goes nowhere. Cosine goes nowhere. Cosine has to turn around. Cosine has to go out there. Back to 1. So this one kind of looks like this. Okay? However, if I go just that much more, now this looks just like sine. Y'all okay with that? So that starts to become a little confusing because sine and cosine really look exactly the same. except they're just shifted. So sine and cosine graphs are exactly the same except shifted. Kind of keep that in perspective, because sometimes they're going to ask you, what is the equation of this graph? And they're going to ask you to put it in sine, or they're going to ask you to put it in cosine, because you can do both. You can do both. If they don't tell you what to put it in, you could put either one. Depends on where you want to start. If you want to start at the high, I'm going to use cosine. If you're going to start at the mid, I'm going to use sine. Fair enough with that? And if you want to start here, I can start with sine. It's just now I'm really starting to do it, except we're going down. So I don't know if I would start here and use sine. I would probably start here and use sine, because now I'm going up. But none of this is wrong. Like, you could start wherever you want. You can start wherever you want. You can start down here if you want. If I'm going to start down there, I'm probably going to use cosine. Okay with all that stuff? Happy, happy, joy. Here we go. Get off this. Properties of the graphs. Okay, so the mid, dadgummit. Are my notes still going with you guys just fine? Y'all will say something, I'm sure. I hope you do. Midline still at 0, amplitude still at 1, periods 2 pi, frequencies 1 over 2 pi. It's all the same. It's all the same. Graph isolates between concave up and concave down. Sinusoidal functions. A sinusoidal function is a function that involves an additive and multiplicative transformations of sine. So that's what they're going to call them. Sinusoidal. The big word. They don't say cosinusoidal or whatever. It's always sinusoidal, even though it might be cosine. Y'all okay with that terminology? They'll always say sinusoidal. It might be cosine, it might be sine, but either way, it's going to be one of those type of things that isolates between a max and a min and has a midline. Okay? That's sinusoidal. That's a sinusoidal graph. 2 periods of a sinusoidal function are shown in the figure above. Find the period, frequency, amplitude, and midline. They're just asking for those things. Y'all okay with a midline being at 3? Y equals 3. Where's that at? That's down here. Y equals 3. Midline is always an equation. It's always y equals. It's horizontal. Y equals 3. Period. I don't care. If you want to start right here, how long does it take to get to repeated? Right here. And if you want to start down here, which I would not because it's not marked. If you wanted to start right here, you could. And then I'm going down, I'm going down, I'm going up, I'm going in, and I'm going down. So it's from here to here. We also know that that's 2 periods because it told me that's 2 periods. But either way, I'm going from 0 to pi. So the period is simply, for that particular one, pi. Where does it start? Where does it end? I don't care. Whenever you start it, when does it start repeating? The frequency is 1 over the period, so that's simply 1 over pi. These are not equations, these are just numbers. These are not equations, they're not. And then the amplitude is from the midline to the max, or the midline to the min. And so the midline is here, and the max is here, and that distance is 3. And that's typically just a number. It's just a distance, it's 3. If you want to say the amplitude is 3, that's fine. Beautiful. I got another sinusoidal graph. Several periods of a sinusoidal graph G are shown in the figure. Find the period, the frequency, the amplitude, the midline. Midline 1. Uh-oh. Let me put a pencil on this. Y equals 1 looks to be the midline. The period, half of a pi. Half of a pi. half of a pi. The frequency is 1 over that. So if I do 1 over pi over 2, if I flip and multiply that, I'm going to end up with 2 over pi. You're just flipping it. It's the reciprocal, right? That's what they said, the reciprocal. So just flip it. And the amplitude is from the midline to the max, or the midline to the min. How about that being 2? Any questions about that terminology? Feel okay? Good, good, good. Example 3. A sinusoidal function has a maximum at pi 8. So here's what I'm going to do. I'm going to draw me something. Let's change color here so I don't confuse us. Maximum at pi 8. That's the maximum. The first minimum after reaching this maximum value occurs at 3 pi negative 2. 3 pi negative 2. That's the first minimum. So now you got to start thinking, okay, if I'm going from the max to the min, I've done half a period. Because in order to do a complete period, I got to go from max to max or min to min. And if I go from max to min, I've only done half of it. Everybody okay? The first minimum, the first max, find the period, frequency, amplitude, and midline. Well, if the max is 8 and the minimum is negative 2, 4 is halfway between that? No? 3? Oh, see, that's why you guys are so much smarter than me. Midline, y equals 3. 3 to get to 8 is 5. 3 to get to negative 2 is 5. Or 8 minus a minus 2 is 10. Half of 10 is 5. I don't care how you do it. Right? Period. Well, if I'm going from pi to 3 pi is half a period, then I've got to go from pi all the way out to 3. I got to go all the way out to 5. I guess the period is 4 pi. And how much math is needed for that? If this was a question, I probably would show something other than a naked answer. But I don't know how much you need to show there, truthfully. The frequency, I'm going to flip that. And I don't think there's much work to be shown there. What else is left? The amplitude. The amplitude is from the min to the max, and we already kind of mentioned that because I said from 3 to 8 is 5, and from 3 to negative 2 is 5. Yes, no, maybe? Everybody okay? Uh-oh. Y'all recognize that? Recognize that from 3:1? It's going to come up a lot of times, this chapter. A lot of times. Because it's a free response question. Not drawn to scale. Not drawn to scale. The figure above shows a large clock mounted on a vertical wall. The clock has an 8-inch long minute hand. 8-inch long minute hand. And the center of the clock is 120 inches above the floor. 120 above the floor. The center of the clock. That must mean when we're at 12, we're at 128. And we're down there, we must be at 112. Whatever. You guys probably get this already. At time equals 0, the minute hand is pointed directly up at the 12. However, the clock is not working properly. Is this the same thing that we went over, right? Almost the same thing we did. In fact, I think this is exact. The minute hand is moving twice as fast. It seems like last time it was maybe moving half as fast, but who cares? It's moving twice as fast as it should. Thus, the next time the minute hand points directly up at 12, time is 30 minutes. It's supposed to be an hour. Now it's 30 minutes. As the minute hand moves, the distance between the end point of the minute hand and the floor periodically decreases. I'm getting closer and closer and closer to the floor, further and further and further and further and further from the floor. The periodic function models the distance in inches between the end point of the minute hand from the floor and the floor of the function time in minutes. Yada, da, 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 da. The graph of H is dashed. The graph of H and its dashed midline for 2 full cycles is shown. 5 points, F, G, K, whatever, are labeled the graph. No scale is indicated and no axes are present. Determine possible coordinates of T, H of T, which T up here is telling me that that's time, and H of T is the distance from the floor to the minute hand for the 5 points. And there's 29 of you cats in here, and there could be 29 different answers. I would hope we would all start at the max point of F, which is at time 0. But that could be 30 minutes. That could be 60 minutes. That could be negative 30 minutes. Is there such a thing? But I would hope we would all start it at 0, but they don't care. I would try to make this as easy as possible. So I would think that F should be time 0. So F should be time 0 at what, 120 plus the 8, 128 tall? Now, Y has to be 128. There cannot be 27 different answers for that. It has to be 128 because that's the max. Then I come to here, and then I come to here, and that's the min, and that's when it's at 6. And then I come to here, and I come to here, and I might do P next. I might do P next because it told me what? It took me 30 minutes to get all the way back around, so that's 30. 120 equals P. And then from here, we just got to figure out what J, G, and K are. Oh, 128, thank you. I can fix that pretty easily. Thank you. Thank you. The 120 happens at what? The G and the K? So the 120 is G and K, and then that must mean that we said 112 is down here. And now you got to figure out your times. If that's 30 minutes, that must be 15 minutes. And so this becomes a little weird. I guess that's 7.5 minutes. And you're okay with 7.5? You're okay with 7.5? And if that's 7.5 and that's 15, and that's 15, 16, 17, 18, 19, 20, 21, 20, that must be 22.5. Y'all okay without me putting all that stuff? And you guys got all that stuff, I hope. It's a free response question that I really expect you guys to nail. Is it always going to be a clock? No, we got the propellers, we got seesaws, we got all kinds of things that they're going to do, and you're going to see so many examples of this that hopefully you get bored of them. Because if you get bored of them, that means you got it. How am I doing on time? 8, we're doing good. Find the period, frequency, amplitude, midline. I don't know why. I have a bad habit of doing midline first. Midline, Y equals 1, 8 minutes, 4, 120. 120. It told me that kind of the beginning. The middle of the clock is 120 away. Midline. Let's see, period. Took me 30 minutes to get through a cycle. You cannot have 29 different answers on that. How long does it take to go through one cycle? What if I start it here? It still takes 30 minutes to get there. To repeat. Period. Period frequency. Well, 1 over 30 minutes. Amplitude. Just don't mess up this. It's from the midline to the max. It's not from the minimum to the maximum. So just be careful about that, and it's not negative. So basically, it's the radius. What's that word? Amplitude. Amp. Questions about that? Hopefully that's easy. Find two intervals where the graph of H is both decreasing and concave up. Holy cow, that was like one of the first things we learned in this class. Increasing. Nope. Decreasing. Yep. But concave down. Whoop. Decreasing, concave up. I'm going to go from G to J. G to J. And we're going to put it like an interval, guys. Put G, comma, J. I prefer parentheses. I think they'll accept parentheses or brackets, but I prefer parentheses. Because truth be told, at that exact point, it's not decreasing. At that exact point, it's not decreasing, but I think they'll accept it. And then we're also decreasing from P to is that it? Concave up, decreasing is from here to here. Okay with that? So, I don't know, R, M. Ray Mayer. This guy. Didn't even notice that we went from 3.4 to 3.5, did you? Probably noticed it because we went to a word problem, but there's not a whole lot of difference between 3.5 and 3.1, right? Yes, no, maybe? Okay. The graph of sinusoidal functions, well, we did 3.4, 3.5, 3.6, we're going to start shifting that graph around. We're going to move it left, we're going to move it right, we're going to move it up, we're going to move it down, we're going to compress it. We don't call it compress, or what do we call it? Dilate. Dilate. We make it easy for you guys. All we say is dilate. That way you don't know if you're dilating it bigger or dilating it smaller. All you have to do is say dilate. Okay, thank you for that. I don't even remember that. Oh, we're going to dilate it here or here. So we're going to do it vertically, we're going to do it horizontally, we're going to shift it horizontally, we're going to shift it vertically, just to kind of put your picture in all this stuff. And really, you know all about how to do graphs. If it's with the X, it moves it left or right. And if it's not with the X, it has to do things up and down. Just to kind of get your head wrapped around that. I won't see you guys again until Monday. Kind of keep track of the calendar, right? But because we're doing pretty good, we're going to have several quizzes. But we got time. We got that big test coming up. Okay? Everybody happy, happy, joy, joy? So, everything, I'm going to hit stop here.